A single U.S. aircraft carrier holds more firepower than most countries' entire military arsenals. But the weapons you see on the surface are just the beginning. Hidden beneath the flight deck and built into the island's structure are defensive systems so advanced they can vaporize incoming threats in seconds. Some use technology that sounds like science fiction, lasers that never run out of ammunition, electromagnetic launchers, and drone-hunting missiles that cost less than a tank of gas. The Navy doesn't advertise these systems, and most people don't even know they exist. Today, you're about to discover the hidden arsenal that makes American carriers the most feared weapons platforms on Earth. Introduction. When most people think of aircraft carriers, they imagine fighter jets roaring off the deck and landing with precision. But what actually protects the carrier itself? How does a $13 billion warship survive against swarms of drones, hypersonic missiles, and submarine threats? The answer lies in a complex network of advanced weapon systems, many of which remain hidden from public view. The U.S. Navy operates 11 nuclear-powered supercarriers, each functioning as a mobile airbase. Every ship can carry around 65 aircraft and more than 4,000 crew members. These vessels are capable of operating for up to 20 years without refueling, launching missions from virtually anywhere in the world, without relying on foreign airfields. But all of that power becomes meaningless if the carrier is taken out. That's why the Navy has invested heavily in advanced defensive systems, building multiple layers of protection around these ships. So, in your opinion, which weapon system on a carrier is the most impressive? Share your thoughts in the comments below. The visible guardians. Let's start with the defenses you can actually see. Every Nimitz-class carrier is equipped with 2 to 3 phalanx close-in weapon systems. At a glance, these automated turrets might resemble R2-D2 from Star Wars, but their role is deadly serious. Each phalanx is armed with a 6-barrel, 20mm Gatling gun capable of firing up to 4,500 rounds per minute. That's around 75 rounds every second. The system operates fully autonomously. Using its own radar, it detects incoming threats, calculates their path, and engages without the need for human input. This is the carrier's last line of defense. When all other systems fail and a missile is only seconds from impact, the phalanx activates, creating a dense stream of fire that forms a barrier between the ship and the threat, tearing the incoming projectile apart before it can strike. Each unit carries approximately 1,550 rounds, allowing for about 20 seconds of continuous fire. The ammunition uses tungsten penetrator rounds, designed to pierce missile bodies and detonate their warheads at a safe distance from the ship. Positioned nearby are the rolling airframe missile launchers. These compact cylindrical systems hold up to 21 infrared-guided missiles, specifically built to intercept incoming anti-ship threats. Unlike the phalanx, RAM systems can engage targets at longer ranges, up to 5 nautical miles. What makes them particularly effective is their dual-mode guidance. In the early stage, the missile locks onto radio frequency emissions from the target's guidance system. As it closes in, it switches to infrared tracking, homing in on the heat signature. This combination makes it extremely difficult to jam or deceive. Then there's the evolved Sea Sparrow missile. These are larger, more advanced interceptors designed for medium-range engagements. Each missile is about 11 feet long and uses semi-active radar homing to track its target. Capable of speeds exceeding Mach 2, they also feature high maneuverability, allowing them to intercept fast and agile threats with precision. But here's something many people don't realize. Aircraft carriers themselves are built primarily for defense. They aren't loaded with long-range strike missiles or heavy artillery for direct combat. Their offensive power comes from the aircraft they carry and the escort ships that protect them, because in modern naval strategy, carriers are far too valuable to risk in direct confrontation. Their role is simple: project power from a distance, not trade fire on the front line. The invisible shield. Now we move into the systems you don't see, the ones rarely shown in promotional footage. Every modern carrier is equipped with advanced electronic warfare suites, designed to jam enemy radar, confuse incoming missiles, and intercept communications. At the center of this capability is the AN/SLQ-32 electronic warfare system, the carrier's primary defensive countermeasure. This system can detect, classify, and disrupt enemy radar signals across a wide range of frequencies. The moment an opposing radar locks onto the carrier, the SLQ-32 identifies the threat and responds instantly, either by jamming the signal directly or deploying chaff. Chaff consists of clouds of tiny metallic strips released into the air, creating multiple false targets on enemy radar screens. To an incoming missile, it becomes nearly impossible to distinguish the real ship from the decoys. Modern versions of the system go even further. With the integration of machine learning, they can recognize new threat patterns and adapt countermeasures in real time. The system's threat library is constantly updated, using intelligence gathered from around the world, ensuring it stays ahead of evolving technologies. But threats don't only come from above. Beneath the surface, carriers rely on the SLQ-25 Nixie torpedo countermeasure system. This towed acoustic decoy mimics the sound signature of the carrier itself. When a torpedo is detected, the Nixie is deployed behind the ship on a long cable, drawing the incoming weapon away from its true target. While the torpedo locks onto the decoy, the carrier maneuvers to evade. Newer carriers also feature the Surface Ship Torpedo Defense System, successfully tested in 2013. This system combines passive detection with active defense, launching a small anti-torpedo interceptor designed to locate and destroy incoming torpedoes before they can reach the ship. And before we continue, take a moment to support the channel. Hit the like button and subscribe. More than 98% of viewers watch without subscribing. It's free, and it helps us keep bringing you content like this. Your support truly makes a difference. The electromagnetic revolution. This is where things start to get truly interesting. The newest Gerald R. Ford-class aircraft carrier has moved beyond traditional steam-powered systems, replacing them with advanced electromagnetic technology. One of the most visible examples is the Electromagnetic Aircraft Launch System, or EMALS. Instead of relying on steam catapults, these carriers use linear motors to launch aircraft. Electromagnetic coils generate a powerful magnetic field, accelerating a shuttle smoothly along a track. In just moments, an aircraft can go from 0 to 170 miles per hour in under 300 feet. This smoother acceleration reduces stress on the aircraft's airframe, helping extend its service life. EMALS is also highly flexible. It can launch everything from heavy fighter jets to lightweight drones using the same system. Aboard the USS Gerald R. Ford, EMALS has already completed more than 9,000 launches, proving its reliability in real operations. But launching is only part of the innovation. Ford-class carriers also feature the Advanced Arresting Gear, AAG, for aircraft recovery. Unlike traditional systems that depend on hydraulics and cables, AAG uses electromagnetic braking to safely stop incoming aircraft. The result is reduced stress during landings and the ability to recover a wider range of aircraft types, making the entire system more efficient and adaptable. Then there are the advanced weapons elevators, another major upgrade. Instead of traditional hydraulic systems, Gerald R. Ford-class aircraft carrier uses electromagnetic motors to power its elevators. These systems operate faster, handle heavier loads, and experience fewer breakdowns over time. They can move munitions directly from deep storage areas to the flight deck in just minutes, rather than hours. All of this electromagnetic innovation serves a much bigger purpose. Ford-class carriers are designed to generate significantly more electrical power than older ships like the Nimitz-class aircraft carrier, producing around 13,800 volts compared to 4,160 volts. This massive increase in power isn't just for current systems. It's built to support the next generation of advanced weapons and technologies still to come. Laser weapons are no longer theoretical. They're here. For decades, the United States Navy has been developing directed energy systems, and they are now reaching real operational capability. Back in 2014, the Navy deployed its first laser weapon system aboard the USS Ponce. This 33-kilowatt laser successfully targeted drones and small boats during testing in the Persian Gulf. When engaging a drone, the laser concentrates its beam on a vulnerable point, typically the engine or fuel system. Within seconds, the intense heat causes critical failure. The drone ignites and falls from the sky, and the cost? Roughly $1 per shot. That was a decade ago. Today's systems are far more advanced. The high-energy laser with integrated optical dazzler and surveillance system, known as Helios, produces around 60 kilowatts of power and is already deployed on escorting destroyers. It integrates directly with the Aegis combat system, allowing it to track and engage multiple threats at once. Helios also uses adaptive optics to correct for atmospheric distortion, maintaining beam accuracy over distance. With an effective range exceeding 6 nautical miles, it can counter everything from small drones to incoming anti-ship missiles. Meanwhile, Lockheed Martin is developing 150-kilowatt laser systems, with 300-kilowatt variants expected in the near future. The long-term objective is even more ambitious: lasers powerful enough to defeat hypersonic weapons. Research is currently pushing toward the 1-megawatt threshold, with Northrop Grumman completing early design work on such systems in 2022. The Gerald R. Ford-class aircraft carrier was built with this future in mind, featuring the electrical capacity needed to support next-generation laser weapons over the coming decade. In time, carriers may deploy multiple laser systems capable of engaging threats across different ranges and altitudes. So why does this matter? Traditional missile defense is extremely expensive. A single SM-2 interceptor can cost around $2.1 million, while an SM-6 can reach $3.9 million. During operations in the Red Sea against Houthi threats, Navy ships launched more than 200 interceptors in just a few months, amounting to hundreds of millions of dollars. Laser weapons change that equation completely. Each shot costs about $1, and as long as the ship has power, it never runs out of ammunition. The drone hunters, this is where things take a new turn. The United States Navy has only recently begun deploying dedicated anti-drone systems. During its 2025 deployment, the USS Gerald R. Ford is equipped with 2 new weapon systems, specifically built to counter low-cost, expendable drones. The first is the Coyote Interceptor, a drone designed to hunt other drones. It launches from a tube, unfolds its wings, and uses autonomous guidance to locate and destroy incoming threats. Each unit costs around $125,000, still significant but far more economical than firing an SM-2 missile at a drone that might cost only a few $1,000s. The second system, known as Roadrunner, takes things even further. This twin-jet autonomous interceptor can detect, track, and engage targets at extended distances. What makes it especially unique is its reusability. If it doesn't engage a target, it can return to the ship, land vertically, be refueled, and then launched again. Together, these systems signal a major shift in naval warfare. For decades, the primary threat came from advanced, high-cost missiles. Now, aircraft carriers are increasingly challenged by swarms of inexpensive drones. launched from small boats or even pickup trucks. Traditional missile defenses remain highly effective against complex threats, but they are economically unsustainable when used against large numbers of cheap, disposable drones. These new anti-drone systems help restore that balance, offering a smarter, more cost-effective way to defend modern fleets. The AIM-174B surprise. This is where things get serious. In 2024, the United States Navy quietly introduced a new long-range air-to-air missile, the AIM-174B. Interestingly, this weapon is a modified version of the SM-6 missile, adapted for launch from F/A-18 Super Hornet aircraft. Its exact range remains classified, but estimates suggest it can exceed 200 miles. Why is that important? Because long-range anti-ship missiles from potential adversaries, particularly China and Russia, pose a major threat to carrier operations. The AIM-174B significantly expands the defensive perimeter, allowing Navy fighters to intercept enemy bombers and reconnaissance aircraft before they even get close enough to launch their weapons. This missile is no small piece of equipment. At roughly 22 feet long and weighing over 3,300 pounds, it gives carrier-based fighters engagement ranges that were once limited to large, ground or ship-based air defense systems. In effect, it reshapes the entire tactical equation for any force planning to challenge. Now, about the Carrier Strike Group. It's important to understand that aircraft carriers never operate alone. A carrier strike group typically includes destroyers, cruisers, and various support ships, forming a layered and highly coordinated defense network. Escorting ships, such as cruisers and destroyers, are equipped with the Aegis combat system, which provides long-range detection and missile defense. These vessels carry dozens of vertical launch cells loaded with different types of interceptors. When a threat is identified, these escort ships are usually the first to respond, neutralizing targets before they ever reach the carrier's own defenses. Attack submarines also play a critical role. Although they operate independently, they move ahead of the group to detect and eliminate enemy submarines before they can strike. At the center of it all is the carrier itself. Acting as the command hub, it coordinates the entire force, managing air operations, directing defensive actions, and maintaining communication with commanders on shore. Future weapons. What we've seen so far is impressive, but it's only the start. The United States Navy is continuing to develop next-generation systems designed to make aircraft carriers even more capable. One potential breakthrough is the railgun. This system uses electromagnetic force to launch projectiles at hypersonic speeds. A single round, costing around 30 pounds, can travel more than 100 miles at speeds above Mach 7, destroying targets purely through kinetic impact. Another major advancement is the development of free electron lasers. Unlike today's solid-state lasers, these systems can generate megawatt-level beams with greater efficiency. In the future, they could be capable of intercepting ballistic missiles or even disabling satellites. While the technology already exists in laboratory environments, it has not yet been fully adapted for deployment at sea. Artificial intelligence is also becoming increasingly important. Integrated across defensive systems, AI can process sensor data faster than human operators, detect threats in complex environments, and support rapid engagement decisions, often within milliseconds. In addition, additive manufacturing is shaping the future of carrier operations. Ships may soon be equipped with advanced fabrication systems capable of producing spare parts and even weapon components while at sea, reducing reliance on shore-based logistics. All of these innovations point toward a future where carriers are not only more powerful, but also more efficient, autonomous, and resilient. Conclusion: the weapons aboard United States Navy aircraft carriers form a layered defense system, all working together to protect one of the most valuable military assets in existence. From visible gun systems to unseen electronic warfare suites, from proven missile defenses to cutting-edge laser technology, every element serves a single purpose: ensuring the carrier and its crew can complete their mission and return home safely. These capabilities didn't emerge overnight. They are the result of decades of research, rigorous testing, and real-world operational experience, and they continue to evolve as new threats appear. The Navy invests billions into carrier defense for a reason. Aircraft carriers remain one of the most flexible and powerful tools for projecting American military strength across the globe. By understanding these defensive systems, you gain a deeper appreciation of what these ships truly represent and why they continue to stand at the center of modern naval power. Behind it all are the servicemen and women who operate these systems with precision, skill, and dedication, helping safeguard their nation every single day. If you found this useful, don't forget to like the video and subscribe for more content on advanced military technology.